Hello friends, today I will solve a LeetCode medium problem on arrays. So the problem says a competition consists of n player numbered from 0 to n-1, and you are also given an integer array skills of size n and a positive integer k, where skills of I is the skill level of player I, and all integers in skills array are unique. All players are standing in a queue in order from player 0 to player n-1, and the competition process is as follows. So the first two players in the queue play a game, and the player with the highest skill level wins. And after the game, the winner stays at the beginning of the queue and the loser goes to the end of it. So the winner of the competition is the first player who wins k games in a row. So we need to return the initial index of the winning player. So let's understand this problem with the help of given example. So I have taken the first example given in the question. So let's say I have a queue called players queue. So this queue contains the index of the players. So there are 5 players and all the players are standing in a queue. So now I'll declare two variables called winner index, and I'll also declare another variable called strict count. So strict count for a player is the number of times that player won the match contiguously. So initially the player at index 0 and the player at index 1 will play the game. Now I can see the skill level of player 0 is greater than the skill level of player 1. So player 0 will win the game. So the winner index will be 0 and the strict count will be 1. And player 1 will go to the back of the queue. Now player 0 and player 2 will play the game. You can see the skill of player 0 is 4 and the skill of player 2 is 6. So here the player 2 will win the game. So the winner index will be 2. As the player 2 is winning for the first time, so the strict count will be 1. Now the player 0 will go to the back of the queue. Now players 2 and 3 will play the game. So the skill of player 2 is 6 and the skill of player 3 is 3. So here the player 2 will win the game. So in this case, the strict count of player 2 will increase. So now the strict count will be 2. And here the player 3 will go to the back of the queue. Now we can see here the strict count is equal to the k. So we can say the winner is player 2. So now let's discuss the second example. So initially all the players are standing in a queue. So the players 0 and player 1 will play the game. So the skill of player 0 is 2 and skill of player 1 is 5. So the player 1 will win the game. So the winner index will be 1 and its strict count will be 1. And player 0 will go to the back of the queue. Now player 1 and player 2 will play the game. So the skill of player 1 is 5 and the skill of player 2 is 4. So here player 1 will win the game. So the strict count for player 1 will now be incremented. So the new strict count will be 2 and player 2 will go to the back of the queue. Now player 1 and player 0 will play the game. As skill of player 1 is greater than skill of player 0, so player 1 will win the game. Now the strict count becomes 3 and player 0 will go to the back of the queue. We can see the strict count is now equal to k, so the winner will be player 1. So to solve this problem, we can use a queue and we can run this process till we find a winner. That is, the strict count of a player reach the value k. But in the problem, you can see it's given that k is less than equal to 10 to the power 9. So if we follow this process, then we will get time limit exceeded error. So now let's observe this problem closely. So let's say the skill levels were S1, S2, S3, S4, S5 till Sn. So there are n players and their skills are represented by S1, S2 till Sn. So we know that first these two players will play the game S1 and S2. So whoever wins, they will be at the front of the queue and whoever loses will go to the back of the queue. So S1 will win the game as long as the elements on right of it are less than equal to S1. Let's say S5 is greater than S1. So S2, S3 and S4 will lose the game and they will move to back of the queue. Now we can see between S1 and S5, S5 will win the game. Then S1 will move to back of the queue. So a player wins the game continuously as long as the scores of the players on its right are less than the current player's score. So once it encounters a player with score greater than the score of the current player, it will lose the game. So in a linear traversal from index 1 to index n, I'll follow this queue approach. And let's say we reach the end of the array and strict count of no player reach the value k. So at the end, the winner index will be the index of the player with maximum skill value. Because here, for example, the player 5 with skill S5 is replacing a player with skill S1 as its skill value S5 is greater than S1. Similarly, someone, and let's say a player I with skill value Si greater than S5 will replace this player S5. So at the end, the player with maximum skill value will win the game continuously and cannot be replaced by any other players. So if we reach the end of the array and will still continue the process, we can see the player with maximum skill will always win the game. So in this case, let's say the skill is 5 in the second example. So now the strict count is currently 3. So you can see now players 1 and 2 will play the game and player 1 will win the game. So the strict count will be 4. Now player 2 will go to the back of the queue. Then player 1 and player 0 will play the game and player 1 will win the game. So the strict count will be 5 and player 0 will go to the back of the queue and here we'll stop because k is now 5. So here you can see, so the player at index 1 has a skill value of 5 which is the maximum value in the skills array. So now even if the k was a very large number, let's say 10 to the power 7 or 10 to the power 8, so this step will continue, but always the player 1 will win the game. So it means once we reach the end of the array, the winner index will be the index of the player with maximum skill value. And if we didn't find any player with strict count equal to k, then at the end the output will be winner index. That is the index of the player with maximum strict value. So now I'll code the solution. So I am declaring winner index. So I'm considering the first player as winner index and strict count as 0. So I'll start from the first index int I equal to 1, I less than skills dot length I plus plus. So if skills of I, that is the skills of current player, is greater than skills of winner index, that is the winner of the previous game, so I'll reset the strict count to 1 and I'll replace or I'll reset the winner index to current player, that is index I. Else if the skills of current player is less than the skills of winner index, I'll just increment the strict count. So here I'll check if strict count becomes k, I'll break the loop and at the end I'll return the winner index. Let's say within the loop no player's strict count reaches the value k, then at the end of the loop the winner index will be the index of the player with maximum skill value. And we know that if we play the game till the strict count becomes k, the winner index will remain same, that is the index of the player with maximum skill value. So now let's run it for the sample test cases. The sample test cases are running fine. Now I will submit it. So you can see it's working as expected. So now let's discuss the time and space complexity. So here we are running a for loop from index I equal to 0 till I less than n, that is the length of the skills array. And within the loop we are doing some constant number of operations. So at the worst case, if we don't find any winner, it will run n times. So we can say the time complexity will be big O of n, and we are declaring just two variables. So we can say the space complexity will be big O of 1, that is constant. Thank you.